All right, good morning. So let's now, very quick reminders. Your programming test 1, I got the files from the TA, so I'm just going to process that very briefly so you can hear back from me about your result and feedback, either later today or early tomorrow for sure. And then you'll get a chance to maybe petition, about the result. That's okay, but I'm going to tell you the instruction once I release the result, either today or tomorrow for sure. And your lab number 3, don't worry, I know I should say I am behind the schedule of releasing it because I haven't really reached to that point to cover aggregation composition. But I'm going to release it on Monday. You will still get enough time to actually do it, so don't worry about it. Just catch up with the lecture and make sure you get prepared for the the written test next Tuesday. And I will release the guide and practice question to you very soon. All right. Okay, so today I would like to definitely finish the object equality. And so far we have really built a solid foundation about how you can override the equals method by the various phases. We did some example last time, but today in the first part we are going to do even more example just to make sure you can put everything together. Especially always keep in mind, the trickiest thing is if you say some object that equals another object, you really ought to define which version of the equals method is being called. That's really what matters. Okay, just keep that in mind. And we're going to go over example. And so if you look at slide number 14, you will see 1, 2, and 3 JUnit test methods. I'm going to go over line by line together with you, make some highlights, and then if I can, I will also show to you on Eclipse. That's equally important. Okay, let's take a look. And we still have the same assumption. Point V1 class does not explicitly override the equals method, whereas point V2, it does override the equals method. So it would be very interesting later when we mix these two together. That's something we'll get into. Let's do some warm-up just before we get there. All right, let's say we got point V1 objects. We got P1 and we got P2. Okay, let's now visualize it. We got for P1 and we got for P2, 3, 4, and 3, 4. You can immediately tell, addresses-wise, they're different, but the contents are the same, right? Let's take a look. This one should be straightforward. It is not the case. P1 is equal to P2 for their address. They're different objects. And also P2 equals P1 also should be false, right? The first two, I'm not going to bother you. However, you should also remind yourself about assert same assertion, which we did on Monday. Right? If you say assert same, it would be equivalent to P1 equals P2. The only difference is this. When you run, for example, P1 equals P2, it is a Boolean expression that's going to return false. On the other hand, if you say assert the same, P1 and also P2, and symmetrically, if you say assert the same, P2, P1, and in this case, not only that it's going to return false conceptually, but also it's going to fail the test, right? That's something you want to be very clear. It's going to fail. So you really want to know the difference between just return false versus fail. Okay? And let's move on. And we can take a look at P1 that equals P2 versus P2 that equals P1, right? And in order to decide which version of the equals method that's going to be called, we should look at the context object. In this case, P1 versus P2. Luckily, P1 and P2, they are both point V1 object. You can also check by the diagram, P1 here and P2 over here, right? So what you need to make sure you check would be, in this case, the context object P1 is referring to these objects. In this case, P2 is referring to this object over here. Right? So we know that it's simply just going to call the default version that's inherited from the object class. Right? Let's just trace one of them. You just remind yourself. This is a simple case. P1 and also P2. That means this will be replaced by P1. OBJ will be replaced by P2. And it simply boils down into checking their references. So that's why you will see assert false. They're not supposed to be equal. Okay? And you can also try to do things that you already know before we talk about object equality. You can simply call the excessive method and check to see if the values are equal. All right? Any question so far for the first one? That should be rather straightforward, default version, right? If no, let me just move on. Anytime you want to things clarified, please interrupt me. Don't be shy. Okay, the second block, let's talk about point V2, which we assume the equals method was explicitly overridden. Right? Let's take a look. So we've got similar setup. So we got P3 here, we got P4 here, 3, 4, and 3, 4. Let's write it down. So 3, 4, and also 3, 4. It's almost a no-brainer. P3 equals to P4, P4 equals to P3. Both of them should evaluate to false. That's why the assert false will simply pass. Right? That's easy. They're different objects. And if you do P3, P4, P3, P4 using assert the same, both of them are actually going to fail because they are not the same addresses. Right? Similar as before. And let's now look at something interesting. If you look at P3 that equals P4, and also P4 that equals P3. Similar strategy. Identify the context object here. So P3 will be referring to this. P4 will be referring to this. Both of them are dynamically point V2 objects. That means we're calling a different version of the equals, which will be the overridden version. Right? That's the one we have been talking about in so much detail. That's the overridden version. Right? And we're going to assert their equality. In this case, P3 equal, let's say P3 that equals P4. Let's do this one only. And the result is actually going to be true. Okay? Because you can see content-wise, 3 versus 3, 4 versus 4. But a little test to you. Which line in the overridden method is actually going to return that true? Is it this line? No, right? Because that one, they're just making sure they are the same objects, but they are not. You can see P3 and P4, they are not. Right? That's important. Then tell me which part actually will give us the true. The last part, right? Yes, I agree. And guys, that's something I'm going to hand wave very quickly for you. But if you got trouble, please let me know. This part here, if you recall, only checking to see where, okay, let me just go a little bit so you can see the diagram. The first phase over here, checking to see whether they are the same objects. They are not. So we don't return true right away. And for this part here, OBJ, the arguments, which is P4, it is not equal to null. So we also don't return false immediately. And then we check to see their dynamic types. Are we comparing apple with apple? For example, in that case, P3 that get class, P4 that get class, both of them will be the same. In that case, the not equal to will just evaluate to false. So we also don't return false. So that means the last phase is where we're going to do the things, right? And you should definitely review what casting really means from Monday's lecture, right? I will refer you to it. And after doing the casting, we will be able to compare X with X, Y with Y. So this will be the part. That's going to be check and return true. All right, so it's going to be, this part here will be true, and also this will be true as well. All right, and then you just want to know it's really this block of code. Okay, and I wrote the assertion slightly differently. So here I say P3 dot equals P4, which returns true. I simply assert true. That's one way to write it. Or I can simply say assert equals and then P3, P4. And if you recall from last time, what would be the difference when I say assert equals P3, comma P4 versus assert equals P4, comma P3? That means the context object will be different, like what we saw above, right? Everything has been said. I think it's a nice brush up your memory, right? Are we okay so far? Well, I'll take silence as yes, you're okay. Next one, let's try to mix them. All right, so this one here, we got point V1, P1, point V2, P2. So that means when you do P1 dot equals P2, it would be treated differently from P2 dot equals P1 because their types are different, meaning that different version of the equals method will be called, right? Let's take a look, okay? Just before that, let me visualize it, and then I want to talk about the comment section here, which is also very important to remind you. Well, I'll get there. Let's try to visualize it. So we got P1, which would be 3, 4. And also we got P2, which will also be 3, 4. Don't be really somehow confused by the diagram. Even though the contents are the same, but since their types are different, you just cannot compare apple with banana. You cannot. Just keep that in mind even before you start tracing. All right, so let me enlarge this part here a bit, just to remind you. And all the source code has been made available to you. So I will maybe try to use Eclipse in one of them, just to show to you. Right, if I say assert false, P1 equals P2, that one is actually, well, P1 equals P2 are actually different objects, right? P1 and P2. So that means assert false is going to pass. Okay, you can definitely try that yourself if you want to. And also, if I say P2 equals P1, also it should be false. So assert false should really pass. Okay. And you can also try assert same over here. In that case, since either P1, P2 or P2, P1, they are different. So it's simply going to fail. I'll put a cross mark. All right, that's what's really said in the comments. And let's now take a look at this one here and this one here. This will be very important, all right? And I'm going to verify this together with you on Eclipse. P1 over here is really referring to this objects, which is of type point V1. And let me use a different color. P2 here is really referring to this object here, which is point V2, right? So we know that they're going to call different version of the equals method. Let's judge one by one. The first one here, P1.equals P2, it is going to call the default version because it's point V1. In that case, it's going to instantiate this by P1, the context objects. The argument P2 is going to instantiate this. So it boils down into P1 equals P2, which is false. All right? Awesome. Boils down into P1 equals P2. Right? So far, so good. And the second one, question for you guys. Can anybody tell me, first of all, is it going to return true or false? This one here. P2 equals P1. I heard false. I agree. But can you tell me which line specifically is going to return that false from the equals method? Cannot be this one, because we know that's not the version that's being called. Josh. Yep. Yes, that's brilliant. Exactly. Yep, that's exactly this line here. Okay, let me highlight it. So you can see this line here, P2.equals P1. That one there is actually going to end up being executed in this line here. Okay, so P1.getClass versus P2.getClass. Apparently they're different. P1.getClass, point V1. P2.getClass, point V2. They are not, They are not the same. So we're going to execute return false. All right. They are both important for you to see. And I'm going to highlight it here and also here. All right. Are we okay so far? If you're really following completely, I think you're definitely on a good track to write a test next week. Good news. Yes? That's correct. The question was, does assert same only apply to reference type? Indeed. So I can make it explicit. So whenever you say assert same, over here, you might pass on expression 1 and also expression 2. Okay. So the idea would be R, expression 1, and expression 2, storing the same object reference. Okay, so that's why both of them must be reference type. Meaning that if you try the following, I believe you're going to have a compilation error. Let's say I got integer I equal to something, integer j equal to something else. If I say assert the same, and then I put I here and j here, That one there, I believe Eclipse is simply going to give you some compilation error because you can already compare addresses for primitive variable. Okay. Yeah. Awesome. Okay, so let me see. Okay, so we're done with tracing these. And then let me do one more discussion here, and then we can take a break by taking attendance, okay? Before we get to the array type attribute for equality, which is a little bit trickier. Okay. All right, so here, the exercise, which I would also go over with you the solution, we want to now switch to a different class called person, okay? Let's say a person has, let's say, first name, last name, also their weights, and also their heights, let's say, 4 attributes. And now we want to define the equals method for the person. We want to override it. And let's say this is something you will see in the style in lab number 3 that's coming, and also possibly in your programming test 2 as well. So you will be told informally what does it really mean for this particular class, like 2 objects of this particular class equal, what does it really mean, right? So here we're saying that if you got 2 objects of the type person, 2 persons are equal if their names and their measures, meaning that the weight and height are the same. Basically, all the attributes are the same value. Right? That's a very typical way of defining them. Right? So now for the equals method, right? This one is rather straightforward. You can think about, it's almost like how you're going to define equality for the point. In the case of point, we just compare x with x, y with y. And here, very similar. So you can simply just do the standard line. Okay? The only difference is, I'll show to you. You can see here, if you count the number of if statements, we actually got 1 less. So this one here, right, if you take a look at this line over here, this one here is more like a combination of the 2. Okay, I'll show to you. I'll try to maybe go back to the original definition. I'll make it very precise to you. Give me a moment. Okay, I think this is good. Let me copy that, and then I'll put it there. We can easily justify that it is correct. Okay, I'll put it here. It's a simple rewriting. Okay, let's say this is the equals method here. And what you can see is this. We got return false over here. We also got return false over here. So that means we can return false either when this is true or when this is true. So that's why we can combine them into one. But when we have the discussion, it's good to separate them. But now that you understand what each one of them really means, you can write a little bit less if you want to. All right, so that's what you will see there is this is one condition there, is one condition there. So we can simply combine them into a single one. So we can say either the object is equal to null, or this dot get class not equal to, etc. In that case, we're going to return false. All right, it's a simple rewriting. You can just notice. Okay, and you can see the first one, the second one here, they're all something we have discussed. They are very standard. And here we simply do some casting. We cast the OBJ, which was declared as objects, into a person. That's what we did earlier. We simply cast OBJ into the point v2. But now we are in different class person, so that's why we cast into a different type accordingly. Okay? And then when we return, we're simply going to say, compare their weights, their heights, their first name, and also their last name. Okay? Let me remind you once again. Here, we really have to do the casting over here because, for example, if you say obj dot weight, for example, this is not even going to compile because the obj, as we said before, is declared with the static type objects, which does not really declare that weight attributes. It was only declared in the person class. So that's why we have to cast that into person. Right? Similar argument as before. Make sure you're okay with it. And as a promise, we'll definitely talk about the casting in much greater detail once we get to inheritance, which will happen very soon. Okay? Are we okay so far about the definition? Okay? Hopefully it's clear. And let's now discuss several things. I got several questions for you. 1, 2, and 3, just to check. Question number 1. If you look at line number 6, which we just discussed, will there be a null pointer exception? Because you can see we are actually trying to say obj.getClass. Whenever you're trying to use a context object here, you have the potential danger of having null pointer exception if that context object happen to be null. Always remember, okay? So in this case, is it possible that we might have a null pointer exception if, for example, let's say the null obj is equal to null. That means this part over here happen to be null. Is it possible? Yes or no? Marcus?
No, because you're already checking if obj is equal to null at the beginning of the system.
Okay, Marcus, let's lead us further. Let's say in this case, if obj happen to be null, what's going to happen when we evaluate this OR operator?
It's going to check if obj is equal to null at the start, and then it's going to be true. It's just not if you can set the part.
Yeah, and remember the term for this is called what evaluation? From Safe guarding, yes, it's a guarding operator, but safe short circuit effects, short circuit evaluation. Just remember the term. Okay, good, both are good, thank you. Okay, let me just repeat very quickly. It's called a short circuit evaluation. Okay, short circuit evaluation, which we discussed last time. Okay, just don't forget the term. And the short circuit evaluation for the OR operator tells you that if the left-hand side already evaluated true, the overall result is going to be true anyway, so we don't need to bother evaluating the right-hand side, right? That's what we said last time. So in this case, if obj is null, that means we're going to evaluate this particular expression first. So we're going to get null equals null, which would be true, in which case we don't have to bother with evaluating this. Effectively, we are preventing from the null pointer exception that might occur. Are we okay with this? Okay, I hope, all right? And a follow-up question, okay? Would it be okay if I swap the order? If you compare this one here that we just showed, it works. What if I swap the order? All right? Ferris. It wouldn't work. Tell us why.
If it's null, then according to short circuit, then we're getting null get class before
Yeah.
we check if the object is null.
Exactly. You check it at wrong timing. Exactly. Brilliant. Okay? Yeah, let me just repeat again what Ferris just said. So basically, just remember, for the short circuit evaluation to work, the order of the operand you put, the guarding condition must be on the left, because that will be the first one to be evaluated. Okay? So now, in this case, what we're going to have is, if you look at this one here, right, this one here, this will be evaluated first. However, in this case, if obj, let's say, happen to be null, in that case, when you try to evaluate it, you got null pointer exception before you even get a chance to check this, right? So you want to make sure the order is so important, right? So this will work, but this will not work. That really captured the essence of the short circuit evaluation. You got to be making sure always put the guarding condition on the left, okay? So for this one here, it's going to give you the null pointer exception. But this one here is okay. All right? All right, guys, a final question for you. Final question. I want you to look a little bit more closely at phase number 4. Here, the weights and heights, they're simply just primitive. So we use equal. We have no choice. And here, somehow we are calling equals. Here's my question. Are we calling the equals here, or are we calling the equals that's inherited from the object class, or are we calling the equals from somewhere else? That's the question. Anybody? Yes, please. The string class. How did you figure? How did you tell? Yes. Yeah, that's brilliant. Thank you. Yes, that's exactly right. And we're following the same strategy as I mentioned to you before. So now if you look at that, the equals method here, both of them, the context object is first name and also last name. So these are the context objects of type string. So that means the overridden version of the equals method in the string class is going to be invoked, which will compare the string by contents. That's the equals method that's already defined in the string class. You have no control over, but you can assume it's just going to compare not the addresses, but also contents, but just contents for the string. Okay, that's exactly right. Are we okay with answers to all the three questions? I think that will definitely help you understand a little bit more about the equals method. Okay? Also the use of the short circuit evaluation. We'll see more example possibly later. Okay? You okay? Okay. And I would suggest we take attendance right now, and then also take a 1 minute or 2 minutes break at the same time before we get into the next example. You guys can just get ready, and then I'm gonna, excuse me, I'm going to get, I already refreshed my location, so we should be fine right off the bat. There we go. Yep, you guys can just check in. If you got any trouble, please raise your hand right away and come to the front. Okay? I presume everybody's okay. Yeah, it's a little bit, unfortunate we don't have that much attendance, but since you guys come, you definitely get a reward at the end. Oh, got some trouble? Okay. Yes. Yeah. If you can just find your name here, it's sorted by last name. Find your name and put a check mark and then sign. Yeah. Okay, everybody else is okay? If I can close it. Guys, last chance. Once I close it, it's done deal. All right? Okay, I'm gonna close it. Thank you. It's now 8:59. Why don't we take a 2 minutes break until 9:01? You guys in trouble again? Yeah, you really gotta sort it out, right? Not really every time. Yeah, I'm not too sure either, but you're gonna sort it out. Anyway. Yeah. Yeah, come. Yeah, just give a sign. Yeah, put a check mark here, please. Yeah, that's good. Thank you. Yeah, just find your name here. It's sorted by last name. Awesome. Thank you. All right, guys, done, right? Good, done. All right. Yeah, take 1 more minute, and then we should really resume. Okay, we'll resume in just 1 moment. Okay, let's now resume. Before I talk about the next exercise, which will have to do with the array type attributes, why don't I show you something very quickly, which you can also reproduce on Eclipse. Specifically, I want to go over that particular example where, depending on the context objects, which can be either point v1 or point v2, the corresponding equals method that's being called would be different. That's something I want to show to you, right? It's really important for you to see that too. Right, if you go under that example projects and go under the points package and test points, okay? You can definitely look at other tests as well. They are also important. Let me now focus on, let's say this one here, the third one. You can see we got point v1 and also we got point v2. And what I want to show you is, if you look at line number 60 and also line number 64, in line number 60, the context object is P1. In line number 64, the context object for the equals is P2. So if I pause there, each line, and step into, I should see a different version of the equals method being called. Conceptually, that's clear, but you want to make sure you also understand that from the Eclipse. Okay, let's do that, which might be useful for your programming test and lab later. Okay, let's take a look. I already put a breakpoint in line number 60, I believe. And then I'm just going to launch the debugger. But to be safe, let me just say right-click, debug as JUnit test. Okay, and switch. Okay, you can see that I'm now in line number 60, right? Now you can see the context object is P1, and P1 is of type .v1. If I say step into now, I'm actually going to see the equals method in the object class. Agree? Let's now try. If I say step into, indeed, that's the equals method, the one-line implementation in the object class. Awesome, okay? Let me step out, and let me step over. Okay, how about this one here? This one here, we got a different context object, which is P2. That one there, P2, has also a different type, which is .v2. So if I step into again, am I going to see the default version? No. We're going to see the overridden version. That's in .v2, right? If I say step into, you can see now I'm in the equals method, overridden in the .v2 class. Right? You can see depending on the type of the context objects, that's the only source you have to look at to judge. That's really the main point. All right? That's what I want to show you. Of course, you can try other tests just to do a similar breakpoint and debug and step into to verify your understanding. Okay. Question? Everybody's okay? All right? Okay, let me now give you a new exercise to consider. And in the slides, you can see the question here. We just discussed them right before the break. Okay, you can look at them. Just make sure you're fine. Okay. Okay, good. Let's say we want to build another class, which will depend on the person. Let's call PersonCollector. Basically, just going to be a class where we got an array of person. Right? That's basically a programming pattern we have been doing since the beginning of the course. And PersonCollector are equal if they contain equal lists or equal array of person. What does it really mean? Let's take a look. And okay, let me just make it, just switch to iPad. Maybe that's easier for you to see. Okay, this one here. Let's look at the PersonCollector. You can see we got PersonCollector class here. And we got person array, just persons. And don't forget, we use a counter, right? Number of person to keep track. Right? And also we got a constructor here, which will just initialize the array accordingly. And also we got add person, get NOP, and also get persons, right? So these are the methods you implemented before for the lab and for the test, right? For that part, I assume you're okay. Let's look at the more important stuff for now. We want to override the equals method in the PersonCollector class. Before the break, we have overridden the equals method in the person class. And now we want to override the equals method in the PersonCollector class. Don't get confused, okay? Let's now go over the definition together. And then I know there might be other ways you can think of to really implement this equals method. I do encourage you to try when you receive the lab and also programming test. As long as your equals method can pass the grading tests and start the test, we're okay. But if you want to check with me about whether your non-standard implementation is actually okay, I'll be more than happy to do that, okay? Okay, let's look at my solution, which does show some interesting bit in terms of logic, okay? This one here, standard. This one here, also standard, right? Remember, we use the OR operator, and make sure you do this guarding condition on the left rather than on the right. And this part here is really the phase number 4, okay? Think about this part here. Starting from here. You can see this part, this phase number 4, is much longer and much more sophisticated than the .v2, which is not surprising, okay? This is phase number 4. Okay, let's take a look. The idea would be we want to compare the array attribute of this and the array attribute of obj, index by index. If their person on index 0 are equal, and also if their person objects on index 1 are equal, and etc., then they are equal. That will be what you will see. First of all, we want to do cast obj into PersonCollector because, again, we got to do this casting because, let me just remind you once more. Because if you say obj dot, for example, NOP, it's not going to compile because NOP was only declared in the PersonCollector level, not at the object level. And the object is the static type here of obj, right? I'm going to keep repeating this. And let's take a look. Eventually, I want to return the value for this equal local variable. I want to return it. Initially, it's simply just false. Okay? I'm saying that if this.NOP and other.NOP, meaning that if they simply got different number of persons that's stored in the collector, they cannot be equal. Maybe one has more persons, the other one has less, right? So they cannot be equal. So it would be a very simple case if their number of persons simply is not equal to each other, in which case this will evaluate to false, in which case we bypass and then just return whatever default value it is, which is false. That's one case. Right? Let's say their NOP happen to be equal. That means at least they store equal number of persons in the array. What should we do? Now I'm going to just change the equal value to be true, okay, from false. And then I'm going to run a loop. And the way I run a loop is very standard. I simply say I should be 0, and then I should be less than this.NOP, not equal to, right? And also I++. And there is one thing here I put, which is very important to note. Equal here. You can see equal is part of the state condition for the loop. Okay? What does this really mean? This means, and we're using conjunction here. This means as soon as equal, remember in the beginning, it is true, right? Before the loop. As soon as equal becomes false, exit from the loop right away. Think about this. Let's say we say PersonCollector 1 dot equals PersonCollector 2, PC1 dot equals PC2, let's say. Okay? PC1 has 1 million person that's stored in the array. PersonCollector 2 also got 1 million. So that means in the worst case, we may have to run 1 million iterations to find out. But including this equal over here can make it more efficient. Let's say we only run the 5th iteration, we found that the person that's stored at index 4 is simply not equal to the person that's stored at index 4 in the other PersonCollector. In that case, we can exit right away, rather than having to go all the way to 1 million locations. That's kind of the idea. Okay? Is it really required? I would say in this course, efficiency is not really the concern. But when you guys go to maybe EECS2030, maybe next term, about data structure, runtime will be a very important concern. All right? But just remember, this is what it is used for. Okay? And let's take a look. So this is to say equal will always be rewritten to this particular expression. So now let's take a look at this expression more closely. Okay? And we have seen something like this, very similar, maybe back in the exception lecture. Okay? Take a look at what I just highlighted in green and answer the following question. This equals method, which version of this equals method is going to be called? We got many possibilities. The default version for object class, we got point v2, we got person, and also we got PersonCollector. Which version is it going to call? The same strategy. Look at the type of the context objects. Before I point to Josh, I'll just see if anybody would like to share the thought. Otherwise, we'll let Josh let us know. Josh, go ahead. Person? How did you figure? Yes. At index I. Exactly. That's exactly right. Let me make it a little bit clearer, if you don't mind, to your classmate. Okay, just for this one here, I'm going to write on a separate page, right? That's really important. And the rest will just be about tracing. So what we got is we are now in the context of PersonCollector. Okay? And then we have this equals method being overridden. And somewhere in the equals, we got this expression. This dot persons I dot equals. It's other dot persons I. And let me also make the context complete. If you recall, we have a person array called persons. That's everything you need to know in order to judge. Okay? Let's look at the context objects. This part over here is the context object for the equals method call. This is the context objects. What's its type? This is referring to PersonCollector, the current class, which is over here. And then persons is the array of person. And at a particular index, it should refer to some member type, which is person. So that means this equals method accordingly is going to be called for which version in the person class. Okay? The version in person class is invoked. You can definitely do the similar exercise by setting a breakpoint and step into, like what I did, to show the point v2 version. I'll leave that to you as exercise. Okay? Any question about this? That's the tricky line. I want to make sure you're okay. Okay? Okay, so that's about the equals method definition, and that's the final slides, which I would like to just trace together with you very quickly. Okay? I think that's really to make the lecture complete. And then we want to talk about something new as well. Okay, we'll see how much we can do. Okay? And this is also made available to you in the example code. You should definitely also look at them as well. Okay, let's now trace them block by block. Okay, I got 1, 2, 3, 4 different blocks. Okay, we'll see. If I'm going too fast, just let me know. Otherwise, I'll assume you're fine. Okay? So we got, in the beginning, 1, 2, 3, 4. 4 person objects. P1, P2, P3, they are simply new person objects. Let's take a look. P1, so we got first name A, last name little a, 180 for the weights, and 1.8 for the heights. Also for P2, also we got A here, little a here, 180, and also 1.8. So far, so good. And P3, we got B 200, 2.1. So we got B here, 200, and 2.1. Rather straightforward so far. P4 is not a new object. Instead, it's an alias. P4 is going to point to wherever P3 is pointing to. So that means P4 is pointing to just over here. That's the setup. Straightforward. Okay? Nothing about equals just yet, but we'll see. P1 equals P2, different objects. So assert false should pass. And P1 dot equals P2 obviously is going to invoke the person version, right? In that way, we're going to compare measure by measure over here. And apparently, they're the same. All right? So think about this equals over here, for example, is going to be the person version. And if we try to run the person version over here, if you step into, what's going to decide will be the final part over here, which is going to check to see their weights, heights, first name, and last name. You can see for P1 and P2, here, 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 and here. They're all the same. So that's why it's going to be true. All right? And similarly, if you try P3 and P4, P3 and P4, and remember what we said last time. If two objects have the same address, does that mean they have the same contents? Yes, it's always the case. Refer back to Monday's lecture and look at that particular discussion. So here, since P3 and P4 are simply the same address, so that means dot equals is always a no-brainer. You can just say that's true. However, for this one here, P3 dot equals P4, we're still calling this version over here, but now which line is going to tell us is true? Do we have to go to this line here? No, we don't have to. Yeah, if you say no, that's a good sign. Okay, it is this line over here. All right, because they're the same objects, P3 and P4. Right? Are we okay with the first block? Good. Let's now move on. Second block, well, it's continuous, right? Just depend on previous one. Let's talk about PersonCollector, okay? And just for easiness, I just pre-draw the diagram. So we got PC1, we got PC2. And when we initialize the PersonCollector, we simply got NOP to be 0. And also let's assume it's always going to be up to 100 persons. Let's just make that assumption. That's why you got from 0 to 99, 0 to 99, right? Make sure you really are convinced this guy here corresponds to these two diagrams, all right? And then PC1, PC2, obviously different objects. So assert false should be passing, right? And what about this one here? Okay, I would say this one is a little bit interesting. I want you guys to do the following little exercise for 1 minute. If I try to trace this code, first of all, it's going to call the version that's corresponding to PC1's type, which is PersonCollector. So it's going to call this version here, which we just discussed. And I need two parts for the answer. Number one, is it going to return true or false? Number one. Number two, which line or what execution path determines we're going to have true? These are the two parts of the question. Okay, take 1 minute and think about it. I would say this is more like a boundary cases in some way for your program to get right. Because if you think about it, so far we haven't stored any person in PC1 or PC2. Conceptually, empty PersonCollector should be equal to each other. But how does the code, the overridden equals, handle this? That's the question. No one. Go ahead. You think that would fail? Okay. Why would it fail? Oh, yeah. Okay, so remember PC1 and PC2, right? Especially for PC1. Both of them have been created, so none of them is null, right? And also PC1 has overridden this version over here. So we are not calling the object version, right? Would you change your answer given that? I'll let you think a little bit more. Mm-hmm. I see what you mean. It is right. Okay, there are two different notions here. Number one, the array itself, they are not null. You can see there is indeed an array here, indeed an array here. It's just that every slot in the array is storing null, which is what the programming pattern is about. However, to determine how many persons are actually stored in the PersonCollector, you have to look at the value over here, right? Mm-hmm. Okay. Anyone want to share some thoughts before I reveal the answer? As I said, it's more like a boundary case that can be solved trivially. But you ought to know which part of the code actually handle that. Anyone? Before I show the answer? Josh, go ahead, please. Return false, okay. Which line will actually let it return false?
It'll get to the final return, but
The value will be false?
it just won't change.
Okay, interesting. Why don't we trace it together, okay, before I really tell you whether that's right or wrong, okay? Let's try. Okay, let's say PC1 dot equals PC2, okay? We're gonna trace this particular version over here. And let's go line by line. This is not equal to objects because these are not the two. These two are not the same objects. And also OBJ, in this case PC2, it is not null. Okay, so we also don't return the true here, also don't return the false here. And you can see here PersonCollector and PersonCollector. So this particular inequality between the get class is also not gonna satisfy. So we don't really execute the return false over here. So we'll get to this part over here, all right, this part. And ecro over here initially is false, okay? I'll just write it down, write it aside. You can think about the ecro initially just false, okay? And then take a look at here. This .nop, which is PC1.nop. Other will be PC2. PC1.nop and PC2.nop, they're both 0, which means we have to execute this line, this block. All right? Maybe that's where you were up to. Let's try a little bit further, okay? Maybe you realize what's wrong, right? That's okay. That's okay. And here, to begin with, we reset the equal to be true, right? Let's do that. Reset that to be true. And then here is the question. What's going to happen when we try to run this loop for the very first time? Initially, I will be 0, and then we got to check this particular Boolean condition. And for this Boolean condition, let me write it down here. Ecro has been set to true. And I initially is 0. Strictly less than, and this is the PC1. PC1.nop is 0. And what would this condition evaluate into? False, okay? And by the way, how does short circuit evaluation go in this case? Because this is true, do we prevent the execution of this? We do not, right? Also, that's really important. So this is going to give you false. Funny enough, we're not going to even enter the iteration for the first time. And we're simply just going to return true, ecro, which comes from this initial value over here. Right? So this is kind of an easy case, but it does require a little bit of thinking here. All right, guys, hopefully you got it. Okay, this one here is going to return true. And I would say not even an iteration will be run. That's important to note. All right? Are we okay with this? Hopefully it's not too heavy. Next block. Let's now try to do a little bit of setting by adding more person. And let's now see this. First of all, we try to do PC1.addPerson, P1. So you can see PC1, we want to add, and P1 is here. And according to our programming pattern, we're going to add from index 0 all the way, right, to the right, right? So now index 0 here, rather than pointing to here, is actually going to point to P1. That's what this line does. Okay? Let's do an assertion right away. PC1 equals PC2. Is it going to be true or false? I heard true, okay. But think about what's happening here. In the previous page, we started PC1 and PC2, both being empty, right? And then in this page, we only modify PC1 by adding a single person into it. We didn't touch PC2. So that means, oh, let me just do one more thing, which I forgot. You can think about after adding P1, we have to update NOP for PC1 to be 1. Yeah, maybe, yeah, sorry, that's my fault. I should have traced that more carefully. Okay, so it's going to be false because if you try to trace this PC1 that equals PC2, let's see what's going to happen. I'm going to highlight a line, this line here. Because if you look at PC1.NOP, it's going to be 0. Oh, sorry, beg your pardon. If you look at PC1.NOP, it's going to be 1. If you look at PC2.NOP, it's going to be 0. So they are not equal to each other. So you are simply going to bypass this part over here. And then equal initially is simply just false. So you're going to return false. Are we okay with this? Conceptually, this is what we have done. We have added only a single person into the first collector, but not the other one. So you're basically comparing some non-empty collector versus an empty collector. Of course, they are not equal to each other, right? All right, let's move a little bit further. And then what we want to do now is adding a person to PC2, okay? Let me use a different color here. So let's say PC2 that add person. Okay, so we're going to add P2 into PC2. And if you look at here, P2 is over here. And we want to add into PC2 the persons. So we're going to let index 0 point to here. And then update this to be 1. Okay? And let's now do a little bit warm up over here. If you try this, okay, let's take a look. PC1.getPersons at index 0. PC1.getPersons at index 0 is referring to this object over here. Is it the same address as PC2.getPersons at index 0? In that case, PC2.getPersons at index 0 is referring to these objects. So we are talking about this versus this. Are they the same objects? No, right? Number one to begin with. So reference equality-wise, it should be expecting false, okay? However, if we try to do this one here, if we say the same person dot equals the same person here, okay? We're basically saying this person here dot equals this person over here. So now we have to call the overridden version of the equals in person class. Agree? In that way, we're going to compare A with A with A here, 180 with 180, and also 1.8 with 1.8. It's going to be equal. Okay? So what I would say here for you to note, the equals here is going to be the person version. Okay? And the next one, if we try to do PC1 that equals PC2, right? Now, what's going to happen? If we do that conceptually, PC1 and PC2, they got the same number of person that's stored in the array. And the person they actually store, this one here versus this one over here, even though they are not the same person objects. But as far as the equality of the person class is concerned, we already verified they would be equal, right? So what's going to happen? This will be the final one I would like to explain for this page, okay? Let's take a look. If you try to do this line here, that means we're going to run this equals method here. And once we reach to this part over here, the NOP and the NOP here, they are the same. 1 versus 1, they are the same. Meaning that we should really go into this block for the if, okay? And we're going to set the true over here. And now, when we try to run the loop over here, it turns out we are going to run one iteration, which will compare index 0 and index 0. In that case, we got index 0 here, and also index 0 over here. And then we'll invoke the equals method here. And then the equals method here is going to be the person version. And that one there, as we know, is going to give us true. Okay? And then, how many iterations are we going to run for the for loop? Only one. Because it's determined by I should be strictly less than this.nop. In this case, only one. So only one iteration, and we are done. Right? So far, the equal is only reassigned to just true, because this person here that equals this person here is true. Right? Once we exit from the loop, we're going to return the final value for the equal, which is true. I'm hand waving quite a bit over here because I thought you guys might be okay to think a little more higher level. Okay? Think about this tracing here, think in detail. You still have time to confirm with me if you got trouble. I'm pretty sure you need this in the test and in the exam. All right? And this one here, the rest over here, just by adding P3 and P4. For that one there, I'm going to leave an exercise for you. You can think about what's going to happen is for P3 and P4, if you try to add them, I'll just show you a little bit. Add a P3, add a P4, they are the same objects. So that means we're going to, index 1 is going to point to wherever P3 is pointing to, update this to 2. And index 1 here, rather than null, is going to point to P4. And then update this to 2. And now, if you want to say PC1 that equals PC2 again, what's going to happen? You're going to get into that loop. How many iterations do you run this time? 2. The first iteration, compare this that equals this. In the second iteration, compare this that equals itself, which is trivially true. So they are still equal. All right? That's kind of the setup. Now, guys, you really want to look at that more closely yourself, right? I'll leave that to you. All right? Okay, the final bit. For the final bit. And so I can have a little bit of time for a call by value today. Okay. The final bit here, not much new, I would say. We basically try the following. So far we already got for let me tell you what we have got so far. PC1 and also PC2. They already got 2 persons. And you can see for PC1, P1 and also P3. For PC2, we actually got P2 and also P4. Right? That's what we have got from the previous page. And we want to do one more experiment. Anonymous objects. Right? So here add person, I simply say new person. That's the notation we learned from the review lecture, if you recall. And if you look at these 2 over here, are they equal objects? New person. Are they the same persons if you look more closely? Okay, if you have a sharp eye, you will see that, no, not the same value. Not the same value. So their addresses are different, and their contents are different either. Okay? So that's why when you try to do this one over here, you're really referring to comparing these 2 anonymous objects. I wouldn't draw them, but this one here is going to compare the 2 anonymous objects. And these 2 anonymous objects will just be over here. They will be added into the PersonCollector. They are not the same. I mean, they are not equal. That's why you were expecting false. And then if you see PC1 that equals PC2, how many iterations? 3. And then for the first 2 iterations, equal remain true. In the third iteration, equal over here is going to be set to false because these 2 anonymous objects are not the same, are not equal. Already then, there's something to remind you when you study that. In third iteration, when I is equal to 2, the 2 anonymous objects are compared. And that one there is going to be false, right? Because they are not the same. You can see the measures over here are not the same. All right? Right? It's only looks like a short test case, but I think it compares many things that you really want to look closely. All right? So that'll be the last example for equality. And we covered quite thoroughly for the equality. And beyond this lecture, I would say the main thing you want to do is to really look at the example code and try to use debugger to really trace the code to see which version is being called. That'll be the number one exercise I'll recommend. And if you want to do a little bit more practice before I release lab number 3 next Monday, you can also go back to your maybe review tutorial or lab 1 or lab 2. You can now define some equals method yourself if you want to, and write some test cases about it. That's kind of the extra exercise you can do. All right? I got about maybe 13 minutes. Okay? So why don't we cover some call by value? Okay? We'll see how much we can do. I'll definitely finish in time, don't worry. All right? Any concern or clarification you need on the equality? Right? This pretty much is what you have to study for the written test number 2. Number 1, you're going to study exceptions. Number 2, you want to study the, I'll get to your question. Number 2, you got to study the exceptions and JUnit lecture. Number 3, object equality. So these are the 3 ones you want to study. The call by value I'm going to cover today. Now, no. You're not going to need to study that. Okay, I'll make it clear in the announcement. Question? Yes. On Monday. On Monday. I haven't released that yet. So on Monday. Yeah, it's my fault. So it was supposed to be released earlier, but somehow I was a little bit slower than I thought I would be on the lecture. So don't worry. I'm going to release lab number 3 on Monday. You still got enough time to finish. Yeah, good. Thank you. All right, guys. Let's now take about 10 to 12 minutes to cover something fundamental but rather straightforward. Let's see how much we can do. Right, it's going to be under the umbrella of aggregation composition. This will be the final lecture, not for the course, but final lecture before we get to inheritance. Okay, so I'm hoping that I can get to inheritance either in the beginning of next Wednesday or maybe the second part of next Wednesday. We'll see. And we're going to talk about inheritance for several weeks, which is a big topic to really go right. Okay, let's one thing at a time. So in this new lecture, we'll start with call by value. You can think about call by value is very useful, especially for you to see how you can trace the code, especially if the parameter is a reference type. That's something you will see. And for those of you who actually are C programmer, that's something you also want to watch out for. Okay, it can also cause some confusion. Be careful. And we're going to talk about aggregation composition, not today, but definitely Monday. Okay, we'll talk about them one by one. All right, call by value. Let's go over one slide, and then I'll sketch some conceptual idea, and then we might just be able to do some example today. Okay, let's start with this. Start with something a little bit abstract. Okay, I'm sure you can do it. Let's say we have a general method call like this. Something dot something with an argument. Let's say we got a context object CO. We got some mutator method M. We got some argument value ARG. All right, let's say that's what we have. Okay. And here, this is something, I'm not sure that might be shocking to you, but that's something you want to remember. We don't really pass the argument value itself directly to the method that's being called for execution. Instead, we are only making a copy of the argument value. This will actually make some difference when you trace the code. Okay, I'll explain that in just a moment. And by these 2 bullet points, I would suggest come back to these 2 bullet points after we have gone through the example. That might make more sense. But one more thing I want to go over. The argument here can either be primitive or it can be reference type, either way. Okay? It can be either primitive or reference. In the case of primitive, we are actually just going to copy the argument value directly. What about the argument is a reference type? That's really important. When we do the tracing where the argument is in objects, so far I simply just say cross the OBJ and then replace that by some other variable name. That's not too bad, but not exactly accurate. So that's why something we want to get right. Whenever there's a reference type for the arguments, you're only making a copy of the address. That's the important point to notice. right? I would say review this slide after we have gone through the example. Let's now do some example right away. Okay? Let's now take a look. I think I can go over these two at least. Okay? Let's say we got two classes here. We got circle, we got circle user. You can think about callee and caller. Okay? Excuse me. In the circle class, we got radius here, attributes. Let's not worry about public, private. Okay? And we got set radius. And important to note, the parameter here R is a primitive type. So this one here is a primitive type. All right? And then we might say this radius is equal to R. Right? That's easy. And this would be where we create a circle object, and then we have some argument here. And you can definitely see this is a primitive arguments. Let me try to trace this once more, and be a little bit more careful to really give you the call by value idea. Okay? Let's see what's going to happen. Start with this line. We say C is pointing to some objects of type circle. And we know circle has radius. The default value might just be 0. Okay? So far, so good. And we have this line here, which is going to initialize an attribute, initialize a local variable, arc. 10. So far, so good. And then this line here, we're making a method call by passing arc here as the arguments. Now, call by value is going to take effects. How does it work? What you want to now notice is when we do this one here, and then think about this method call. When we do it, actually, what might be the best way to draw the arrow? Maybe like that, okay? Something called call by value. Call by value is actually going to make a copy of the value of the arguments, which is going to be 10. And then the name is going to be just the parameter R. So R here, due to call by value. R is a copy of arc. So now, when we try to trace this line of code, when we say this radius, C radius should be reassigned to R, we are really referring to R over here. We are not really referring to arc over here, even though they have the same value. Because in general, we may decide to change the value over here in the method, which will keep this original argument value untouched. Okay, that's really easy. That's important to remember. Okay, so now I'm going to do one more, and then, okay, we've got 5 more minutes. R is really referring to this. And R is not referring to the original arc anymore. Okay, it's a copy. That's called by value for primitive arguments. Are we okay so far? For the reference type for the arguments, follow just the same principle, except we're copying the address. Okay, that's actually something interesting. Let's take a look. Similar example here. We got circle, we got radius, we got constructor, and also we got the primitive type parameter mutated method, right? Let's say, the constructor, sorry. Let's say we got another one here, set radius. And now this time you can see this circle here is the reference type parameter. And let's trace line by line. See here. So we are creating a circle C. Every circle has radius. Initially has the value 0. Okay, so far so good. And then we have some argument here. The argument itself is a circle. right? So what we do is I'm going to say arguments over here itself is also a new circle. And the new circle here has the radius to be set to be 10. Okay, so far? And let's see what's going to happen when we do this. This one here, we're going to apply this call by value idea again. When we actually make this call, we're going to have call by value. Meaning that the C over here, the parameter, is going to be a copy of arg. What does it really mean to make a copy of the address? Are we creating a brand new object? Not really. C here is just going to be an alias to the same object arg. That's really the visual image you want to have very solidly, to really understand what's going on. Okay, and then when we say this dot radius is assigned to C dot radius. So now if you look at that, this dot radius will be C dot radius. What should we set it to be? It's going to be C dot radius. And the C dot radius is really 10. And you want to notice this. Let me make one more remark and then we're done. So here C is referencing the same objects as pointed to by arg. Right, call by value, let me recap. Before next Monday, before we dive into some more example, call by value means whenever you want to make a method call, the argument value, primitive or reference, is going to be made a copy in order for the parameter to actually have some value. In the case of primitive value, you just make a brand new copy. Changing this is not going to affect the original arguments, as you can see visually, but we're going to prove that by some example. In the case of reference type arguments, in that case, what you're creating is not a brand new object. No, you're just creating a new alias of the name of the parameter that will be pointing to the same objects. In that case, there are two possible changes you can make. I'm looking ahead a bit. If I simply, let's say, redirect C into some other objects, does it change arguments? No, it doesn't, visually. That's one kind of change we can see. Number two, if we try to say the object that's being pointed to by C, why don't I change its value here? In that way, can the original argument see that change? Yes, it can, because it's still pointing to the same objects. So these are the two kind of changes you might make by call by value, which is something we're going to dive deeper on Monday. All right, thank you so much. And then I'm going to reach out to you about the exact coverage for written test 2. And also I'll give you some practice questions as well by the end of tomorrow. All right, you guys take care.